All right, welcome back. We're going to do part 2 now, finish up section 7.1. So we're going to look at computing arc length and arc length of a sector of a circle, and then we're going to do the area of a sector of a circle. All right, so the formulas seem pretty easy, which they are. So if you'll look at arc length, so remember an arc length is the distance between the two rays of an angle, okay? So to do the measure, to do the formula, you just need the radian, the radius, times the angle measure. But here's the catch, and this is what some of you will do wrong. The angle measure must be in radians, okay? You can't put a degree in this formula. So it sounds easy enough, but since we're just learning about radians, you've got to remember to do that. All right, so example 9 says, find the exact length of the arc intercepted by the central angle. Okay, so that's an arc length problem. And it gives you the radius, and it tells you to round your answer to the nearest tenth. So this one, we're going to be putting pi in the calculator and getting a decimal answer. All right, so always pay attention to the angle they give you. So this one is in radians, so I'm going to put a check mark here. We're good to go. This one over here, they give you 20 degrees. That is not what we want to put in our formula, okay? So this one's ready. So the arc length, which is denoted by the letter S, is the radius times the angle measure in radians. So the radius in this problem is 14, and our angle measure is pi over 12. So we're going to do 14 pi over 12, which will reduce to 7 pi over 6. So if they wanted an exact answer, that would be it. Okay, but they asked to do this decimals. So you're just going to put 7 pi in your calculator and then divide that by 6. Okay, so 7 pi, you can put it in just like that. I usually hit enter to make sure it multiplies, and then I do divide it by 6. So we're rounding to the nearest tenth. So 3.7, and these were meters. Okay, so again, that's approximation. That's not an exact answer. All right, now, for part B, I can't use 20 degrees. So I need to change 20 degrees to a radian. So remember, you multiply that by pi over 180. So that's going to give you pi over 9. Okay, so pi over 9 is the radian. So that's what we need to use with our radius. So now we can find the arc length, which is just r times theta. So that's 2 times pi over 9. Okay, so the exact answer would be 2 pi over 9, but we're going to multiply that or divide it. So put in your calculator 2 pi divided by 9, and you should end up with 0.7, and these were feet. Okay? So please be careful. They're always going to give you problems with degrees, so just make sure you change that up. All right, the same goes for area. Formula is a little harder, not much. It's 1/2 the radius squared times theta, but again, theta has to be in radians, okay? So I'm going to look at the problem. I've got a circle with a radius of 12 feet. Find the area of a sector made by an angle of 135 degrees. So I can't use that. I need to change that to a radian, which we've already done. That's one number you should know, that 135 degrees is the same thing as 3 pi over 4. That's why it's good to kind of know these. But you could work it out like we did above and do 135 times pi over 180. You'll end up with 3 pi over 4. All right, so that's the number we need to use in our formula. So the area is 1/2 radius squared times theta. Now notice it says find the exact area. That means no decimals. Okay, we're going to leave pi in our answer, no decimals. So we're going to do 1/2 the radius squared, radius was 12, times our angle, which is 3 pi over 4. Okay, now however you want to solve this is fine. I'm just going to do order of operations. So I'm going to square first. 12 squared is 144. Okay. Then I'm going to multiply 144 times 1/2. So I'm just dividing that by 2. So that's 72 times 3 pi over 4. And now I can do 72 times 3 and divide that by 4. So 72 times 3 divided by 4 ends up getting me 54 pi. Okay, that is an exact answer. I left pi in there. I didn't multiply it by 3.14. Okay, so pay attention to your directions on your homework, whether they want a decimal or an exact answer. Okay. All right, so you need to know those formulas. Remember, you're not given any formulas, so please start learning those. All right, the last page of this, I just want to talk to you a little bit about this circle, okay? Because you guys need to know this like the back of your hand. So, let me get it so it all fits on here. Guess it's not going to go down anymore. Okay. So this is what we call a unit circle. So we just are looking at these basic angles that you guys are familiar with. So these are the 30, 45, and 60 degree angles in each of our quadrants. So 30 degrees are all the angles that kind of are 30 degrees away from the x-axis. Remember, you always start on this horizontal. So 30 degrees, and then 150 is also 30 degrees away from here. 210 is 30 degrees away, and so is 330. So those four angles have a good relationship, which we're going to learn about in the next few sections. But what I need you guys to know is what are the radian measures of these, because we're going to use these a lot, and we're going to use the radians. So we've already done 60 degrees, that was pi over 3. We've already done 45 degrees, which was pi over 4. And we've done, I don't think we've done 30 degrees, okay? But if we do 30 degrees times pi over 180, we end up with pi over 6, okay? We've already talked about 90 degrees is the same thing as pi over 2, right? Because all halfway around the circle is pi, so that's 180 degrees. So half of pi would be up here, 90 degrees. We've talked about 135 degrees, 3 pi over 4. Okay. We talked about this angle down here, 270. We already did that, 3 pi over 2. Okay. So what you need to do is fill in the rest of this chart. Okay. Whether you use the formula or not, you can multiply by pi over 180. And write those radians down and keep this handy with you, because we're going to use it until you get familiar with where the radian is compared to its degree. Now I'm going to show you little tricks along the way, but for now I would like for you guys to finish this and write all the radians in there. You can look online, obviously, you can see there's plenty in your book as well, but try to do them yourselves just to practice. And then we'll talk about this next time when we start with section 7.2, and I'll again try to help you with some little shortcuts to help you remember. Okay? All right, so that's it for that section. Work on your homework, and honestly, to do well in trig, you got to do a little bit every day, and you got to memorize this stuff. If you have to keep going back or keep doing formulas, then you're not going to be prepared for your test, because you need to be able to do these things quickly. Okay? So let me know if you need any help. Otherwise, keep working on your homework, and I'll see you back here next time.